So now let's try to incorporate everything in one question that we have learned till now. In the system shown, a block of mass m1, which is 5 kilograms, slides on an inclined plane at an angle of 30 degrees. The block is attached by a string to a second block, m2, which is 3 kilograms. The system starts from rest. The block 2 hits the floor. Find the acceleration of the block and the tension in the string. Take into account frictional forces between m1 and the plane. Take mu s to be 0.24 and mu k to be 0.15. Now this is a very good question because it involves incorporates a lot of ideas that we have talked about till now. Okay, as always, we will start by drawing a picture. Okay, this is going to be my picture, and my angle that it gives me is 30 degrees. So this is 30 degrees. I'm just going to call it theta. And there's a pulley here, and there's a mass that's attached to it, and then there's another mass that falls below, right? So this is M1, this is M2, and this is its tensions. Tensions will always be away from the masses, and so on and so forth, right? Now the most important thing in these questions is to choose your coordinate system. So this is going to again use the concept that we talked about a little bit before, and that was bent coordinate systems. So let's start. I choose x and y to be my coordinate system. And now what is going to happen is that this coordinate system is going to go all the way over, and it's going to bend as it goes down. Okay? So this is going to be my y, and this is going to be my x. It sounds a little strange, but this is one question. You can't really choose two different coordinate systems in one question. So once I've chosen a coordinate system, I better stick to it. So it's going to be like this L sign, x and y, going on and then falling off the cliff. Okay? So that's going to be kind of what my idea is going to be. So now, let's talk about all the forces that are acting on these two masses. Well, there is going to be always a normal force that acts normally to the surface. I'm going to call it N1, as long as it's resting on it. Then there's going to be mg that acts downwards all the time, m1g. For my mass 2, I am going to have a m2g that acts downwards, and a tension 2 that acts upwards. For my mass 1, I am going to have a tension 1 that acts on the side, and also I am going to have a frictional force. So the question tells me that this mass is going to go and hit the floor. The only way for this mass to go and hit the floor is if this mass is accelerating upwards. That means my frictional force has to oppose the motion, and so my frictional force is going to point towards the negative x direction. Okay? Now, two masses. That means we have to treat them as individual two masses, and these both will now become m1 and m2, and we have to write force equations according to both of them. So let's start by writing the force equations for m1. Okay? Sigma fx1, sigma fy1. How many forces are acting on M1? Well, here's the trick. Note what's happening. This one is normal to the surface, N1, but M1G is not according to any of my coordinates. So I have to find the components for them. Okay? And this is it. Using head to tail rule, these are the directions. See? Head, tail, tail, head, tail, head. It is the sum of the forces, right? And this angle right here will be the theta that we had here. So this theta is the same theta of that. So that means this is 30 degrees. So, and that is M1G, pointing downwards, okay? So by definition, this is going to be M1G sine theta, and this is going to be M1G cosine theta. Okay, so these are all the forces that I have for M1. So F1y will actually be the component M1G for this, then that means it's going to be minus m1g cosine theta, right? And for F1x, it is going to be tension 1, which is plus, because it points in the direction, minus frictional force 1, which points in that direction, and minus m1g sine theta. Do you see how that works? I have this force, and that force. All of them will come into F1y. Okay? Now, for M2, what do I have? Let's see. For M2, I have sigma Fx and sigma Fy. Okay? Note this is now going to be your x coordinate, right? So this means this is going to be minus T2, because it points opposite to my point minus x, plus M2g. And is there anything along the y-axis for M2? Nope, so I'm just going to ignore that. Okay? Let me call this equation 1, this as equation 2, and this as equation 3. Now what do I know? I know since both of these masses are attached together, they should have the same tensions and they should have the same accelerations, right? So because this is an accelerating system. That means I can rewrite this as M2A, and since this is falling down, it is along the positive x-axis. I'm going to call this positive M2A. And this one, I'm going to recall it M1A. It is again also equals to, it is also going towards the positive x-axis, so I don't have to worry about plus or minus here. And this one I call 0 because there is no motion of M1 along the x or y-axis. The y-axis. Okay? So this means this equation can be rewritten as M1A equals T. Note I'm going to drop the subscript. I'm just going to call it T. Mu1 N1 minus M1G sine theta. I have plugged in the value for friction here, right? Frictional force equals mu n. From equation 2, I get N1 equals M1G cosine theta. Okay? So I can plug this value into here. So this implies my equation 1 will now become M1A equals T minus mu M1G cosine theta minus M1G sine theta. Am I missing anything? I have an M1A, I have a T, I have a mu1, M1G cosine theta, M1G sine theta. Good. So this is a good equation. Okay? Now, for this one, what will it become? Equation 3 can be rewritten as M2A equals minus T. Again, I'm going to drop the subscript. Plus M2G. Okay. So now this is also a good equation to know. Now I have two equations and I have two unknowns. I can actually plug in the values of M1 and M2 here, which they've already given me. So M1 is now equals to 5A equals T minus mu1 that they already give me is 0.15 times G cosine of 30 degrees minus 5 9.8, which is G sine of 30 degrees. Right? This one, M2, it gives me is 3A equals minus T plus 3 9.8. So basically my equations 1 and equations 3 can reduce down considerably. So I can rewrite A as minus T plus 3, let me just call it G because I don't want to do the math right now, okay? Divided by 3 this I can plug back into here and solve for t, because everything else is going to be for in terms of t. And then further, I can solve for a and plug it back into t. So quickly do this, and my answers, this just involves a little bit of an algebra, and I'll give you my answers. Please confirm if you get the same answers. So upon solution, I get the value of a to be equals to minus 1.61 meters per second squared, and my t value comes out to be 22.82 newtons.